All right, welcome everyone. Welcome, welcome. We're so excited to have you all here today. Thank you for joining us for another webinar in the AI4 webinar series. Today's webinar is titled Finding ML Success in Financial Services with ML Ops. We have two awesome speakers coming to you today, and I'm so excited for them to join us. Just a couple of housekeeping items before we get started. Please use the Q&A box to send your questions in to our speakers. This makes it easier than the chat for us to manage the questions, and we want to make sure we answer as many as possible. So please make sure that you're putting any questions that you have in the Q&A box. Thank you so much. And now I'd like to welcome our panelists to our virtual stage. So Diego and HP, please join us with your cameras. Thank you so much.
Great. Thanks everybody for having us today. Excited to have you, and obviously always excited to be talking with HP on any event. So let me quickly here share my screen, and we will get started today. So HP, can you give me a thumbs up if you can see my screen? Perfect. Great. Today what we'll be talking about is essentially some of the kind of risk and governance factors that are required in financial services, and how machine learning and some considerations that need to be taken from a machine learning perspective. So really looking forward to getting your questions as well, and hopefully you find today's session informative. So I'll let HP introduce himself. Huge experience in the space, but why don't you introduce yourself here, HP?
Oh, thanks, Diego, and yeah, real pleasure doing this with you today. Hi everyone, and thanks for joining. My name is HP Bunaes. I'm a 30-year veteran of financial services, pretty deep experience in data and analytics, which I've been doing virtually all my career. And have done a lot of work recently in auto ML with data robot, ML ops with Algorithmia, and have done some articles and papers on managing AI and managing analytics and the governance framework. So very happy to talk to you today, and happy to be here with you, Diego.
Absolutely. Great. To introduce, very quick introduction myself, my name is Diego Oppenheimer. I'm the CEO and founder of Algorithmia. We are the enterprise ML ops platform. Just like HP, has spent most of my career in the world of data and analytics, and a lot of it in financial services, actually, where I started my career. So with that said, let's get started here and jump right into it. So HP, why don't you talk us about, what are financial services faced with today? What does this landscape look like?
Yeah. So, some of you may get the question, what's the big deal, right? You build predictive models, you acquire some data, you train the models, you make some prediction, that result goes somewhere and some action is taken. Why all the concern? And Diego, if you hit the button here, the problem is that over time this happens. You get an enormous complexity grows, and often it grows exponentially as you add more models, as you begin to acquire more data, as you begin to deploy models across your enterprise. And the problem is these may you may have overlapping, potentially inconsistent data flows. You may have chained models where results are feeding other models that combine the results of previous models. This is done a lot in the credit space and in the financial crime space in banking. These may be deployed across different platforms. They may have been developed by different people at different time, using different tools. And this becomes a very difficult environment to manage change. As data changes, as models change, as requirements change, as new things are implemented, to really understand sort of what you've got and how to manage it all, over time. So, I've done some work on sort of a governance framework for analytics, and the problem is that a lot of the sort of IT governance framework and some of the traditional data governance framework aren't adequate for this new space. In this space, you really have to be able to answer sort of a whole series of questions, and I've got 15 here that I'll run through really quickly. Number one, you have to have a good inventory of your models, right? What models are out there? Where are they? What data are they using? What results are they producing? Where are they going? And who's using them, and why and how? How have you sourced that data? Which platforms has it come from? How have features been engineered? How has data been synthesized and integrated? Have you maintained some sort of standards so that people are looking at things consistently? Do you have potential breakpoints in the way data is sourced? Is that data good quality, right? Is it not only relevant for the purpose, but is it appropriate for the purpose? And is it of sufficient quality and depth for what you're trying to do? And do you know where the results are going and how they're being used? In many banks, we find that there are undeclared users of models, people who are consuming or using models that you may not be aware of, and that's something that's fairly common. Number 5, are your models well documented? I think I can say from experience that most data scientists do not love to do documentation. And in many cases, you may find that, model documentation is outdated, missing. Maybe it's got some big gaps. Maybe the people who developed the models are long gone. So you really need to know, do I have gaps in the documentation of these models? And you need to know how a change in upstream data or a change in what a model is doing or what results it's producing may affect downstream to other models. And I've got some a couple of anecdotes that I'll share with you later about what can happen when you don't have that knowledge. Number 7, can you explain how the models work? So explainability is a really big issue. Trust is a really big issue, right? You need to not only ensure that the models are valid, but you need to be able to explain what they're doing, how they're doing it, which data is being used, how that data is prepared, how predictions are made, and even be able to explain individual predictions, right? In credit, for example, the model may say this is a very good risk. Why? Or this is not such a good risk. Why? Right? Or this could be fraud. Why? Or this appears not to be fraud. If you can't explain the models, then getting adoption and usage and trust is a really big issue. Number 8, not all models are created equal. Some models are really risky, right? Have significant financial risk, operational risk, reputational risk. Some models are much less risky, right? They may be used in an isolated part of the company, and in a way that if they were to fail or produce a wrong answer, it's not really that big a deal. But one of the biggest mistakes that I see is not really having an effective risk rating structure for the models, so that you're putting the appropriate amount of attention over the models that need it the most. Number 9, how accurate your models are, and this is easy to do during the training and validation of the models, but that's not good enough. You need to know how accurate have they been in deployment, right? Has that accuracy, withstood the test of time? Is it uniformly accurate across the population? You need to be able to describe not only model accuracy at a point in time, but as those models are used and as the environment changes both internally and externally. Number 10, are your models performing adequately and meeting SLAs? You may say that I want a turnaround time of X seconds on a fraud model, or maybe a little bit more on a credit model, or if it's being used to make trading decisions in millionths of a second. But you have to make sure that not only are the models producing valid results, but are they doing so with acceptable latency? Is drift occurring? So this is something that happens in many models without anybody knowing it, right? The data subtly changes over time. It doesn't change very suddenly or dramatically, but over time, it begins to look significantly different from the data that the model was trained on. Or, and this happens a lot in financial crime and in credit, people learn how your models work and may learn how to game the models. So you need to see whether, the outcomes, the predictions are starting to become, biased one way or the other. Are you actively monitoring the models? And, this is as much art as it is science in the realm of analytics. In the old DevOps, sort of days, monitoring application health, it looks relatively easy compared to, monitoring models, because the failure of a model may not be, something that is blatantly obvious, right? It may be more subtle, right? The model is producing what appears to be a valid result, but it's, something smells fishy, right? It's beginning to produce some really strange results for certain populations. So you need to monitor your models, not just for the obvious things like failure, but the less obvious things like, it's beginning not to work as well in certain areas. 13, model changes. Are you logging all the changes? Are all the history of changes known, so that you can go back and explain, to an auditor or an examiner, right? These are the changes we made to improve the model or to fix certain things, and here's why we did it and when we did it and who approved it and how we tested it. Those things are really important, especially if they ask you to go back and explain, sort of why was the model at a point in time different than the model today. 14, do you have a process for issue management and tracking? I can tell you from experience with examiners and auditors, if they walk in and you say, here are the open issues around all of our analytics, right? Things that we're working on. They then will use that list and make sure that your process is robust and you've got follow-up and remediation dates and plans and appropriate prioritization. If you don't, they're going to start to turn over every rock and try to find all the issues themselves. You don't want that to happen. It's much better if you have a list of all the issues prioritized with remediation dates, with people responsible assigned to each one, that your audit or exam will go far better if that's the case. And then last, you have a failover plan for critical models. If a model fails, like a model used for fraud or for credit or for trading, and something happens, something breaks upstream, or the model ceases to produce results, what happens, right? What's your plan for that? Do you take that particular product offline or that activity offline, or do you default to some failover model that is perhaps less sophisticated but adequate for the purpose? Do you have some manual review process that you're gonna fail over to? But it's really important for your most critical models to know, what are you going to do in the event that there is a failure.
Great, thanks for covering those, HP. So, one of the things that's really clear is that as we advance, more and more applications being powered by machine learning, and more of these models are coming in, there's a new really governance framework that's required to start thinking about it. So to start with, and I like using this graphic here, the development of machine learning models and analytics is probably it's the fastest moving quote unquote software team in the history of software development, right? So like the iteration speed is really incredible. And so if you start thinking about, I'm developing, new models, I'm deploying them, I'm operating them, and then I have feedback circles and kind of go through that process. When we look at a traditional software development lifecycle, and the stages of, kind of like build, deploy, monitor, we do that potentially every minute in the world of machine learning, right? So automation, automation, automation. And so when you start thinking about that, how do we actually group the different categories and the different stages? So the requirements for governance that HP talked in some of them, where did the data come from a development perspective? How do we track our experiments? What features are we using? What, like how do we get to the results? What were the training sets we verified again? There's an entire concept around kind of like where I'm doing ML dev or ML development and a security aspect to that and a governance aspect that I'm required to apply to that. And then we move into what we call more the production side of the house, which is the deployment and operations, which requires a different set of kind of governance and security systems, especially if you're going to be actually using machine learning for operational systems like HP covered, like fraud detection and risk management. These are operational systems for the organization. The level of security and governance that are required for those systems is much higher. Just based on internal controls, there's a new level. And so when you start thinking about a government model that can actually take advantage of development, deployment, and the operations of AI-powered systems, we have to start thinking about, okay, how do we take advantage at the deployment stage? Are we connecting to the data services and using the security and governance frameworks that have been declared for those data management systems? How are we actually deploying models and versioning them and tracking the versions and registering them in catalogs so that we can understand what every model got deployed, where, who did it, and where we got to that? And then finally getting into the operational aspects, which gets to, are we actually complying with IT security and governance models? Do we have the right security controls from a network and data and model and people perspective? Are we running in the right infrastructure? Are we using the right compute environments? Because that could be for GDPR reasons, geographic reason. It could be, we have different controls for cloud versus on-prem. And then how are we monitoring and reporting all of this? And monitoring is not just about what HP covered. Hey, do we know what the model's doing and how it's doing it? But like, how do I actually create these audit trails? How do I understand what systems are using it and track back? And so we need to start thinking about the modern software that's going to be used in banking, which is going to be driven by machine learning models and advanced analytics. And how are we going to actually fit into the operational systems of that organization from an audit perspective, from a security perspective, and from a controls perspective? So a lot of the stuff that we're going to cover over, the next couple of minutes is really going to be how to think about the different, so one way of framing all of this is where are the risks and what are the controls around those risks that can be actually applied? And so, and this is, again, if you kind of forget the world about ML and just apply this to IT and how a bank would think about IT, they would do the exact same thing. What are the threats? What's the threat model for this operational system? And what are the risks? And what can I do to control those risks and how to approach them with people, process, and tools? This is not just a tool solution. It's not just a people solution. It's not a process. It's the combination of all three on how we drive to being able to operationalize these data systems and ML systems inside financial organizations. So with that said, maybe HP, if you want to introduce the roadmap to AI governance, and we can kind of talk around that a little bit.
Yeah. So what we've done, the governance framework can sort of be a complex and difficult topic to talk through. So what we've done is sort of created this pie, if you will, and we're just going to walk through what we think to be the most critical elements. 7 of them, one step at a time. So let's start with the first one. So I actually had a conversation not that long ago with the chairman of the audit committee of one of the largest financial institutions in the country. And we were talking about the governance framework. And how it should work. And he asked a very simple question. He said, where do you start? And I thought that was a really good question. And if I was going to start anywhere, it would be here with a complete model catalog. You'd be surprised how many organizations don't know all the models that have been developed and deployed and are in use. One very large bank in the U.S. did a survey about a year and a half ago and found thousands of models that had been developed outside any formal oversight or supervision. And that's a sort of daunting set of circumstances where you don't know necessarily who developed these and when they developed and who's using them and what data they're consuming. But at least if you have a complete catalog, then you can begin to prioritize. You can begin to assess risk. You can begin to figure out what a remediation plan is, which ones you're going to try to, fully document or validate, or maybe do challenger models, or put some better monitoring around them. But if you don't know what you have, it's very difficult to sort of try to get a handle on how to go about it. So if I was going to start anywhere, this is where I'd start. The second thing is a flexible model risk management framework. And by this, I mean, not all models are created equal. There's one big bank that I did some work with that had a one-size-fits-all model framework, regardless of the nature of the model, the data the model was using, the results it was producing, what it was being used for, who was using it. It went through the same process. And a model that was simply retrained on new data went through the same model risk management and approval process as a brand new model. And frankly, I just think that's crazy. I think you've got to think about, how do you put more oversight and controls and validation and requirements around the most risky models, and much less around the least risky models. If you've got a model that's, for example, going to some external body, let's say a regulator, or it's used in investor presentations like a loss forecast might be in banking, then those models really should have uber governance and oversight and controls. If you've got a model that's used, say, to sort referrals from best to worst in a wealth management group, well, that model probably doesn't need a lot of controls, because if it fails, you're not really any worse shape than before you had the model. I think it's valid to say there's some class of models where you don't have many controls at all. You sort of leave it to the local group. But there's some models where you need really, really tremendous, and potentially invasive and intrusive sort of controls, because of how sensitive they are, either financially, operationally, or reputationally, or from a regulatory perspective. So, the message here is, you do not want a one-size-fits-all model governance framework. You need to think about how you differentiate risk. One bank in Australia I worked with had a 7-tier risk management framework, which might be more than most banks need, but I thought it was very, very well thought out and very elegant.
One of the things I really like on the framing here, HP, that it really helped me kind of think about it, which is kind of that pendulum of risk, right? So on one side, you have the risk, and why this flexibility is important, where you're saying, okay, well, the reputational risk, like if we do something bad and it's going to affect our brand in some way, I remember my first day working at Barclays Capital, the first thing that they told us was never do anything that's going to show up on the front page of the Wall Street Journal. That was the orientation around that, and then so that reputational risk is obviously extremely important, and then there's obviously operational risk, of like, well, if we do something, we lose a bunch of money, or we miss a bunch of fraud, or, we make bets that we shouldn't be making. But there's and you can minimize those two risks, like, almost, down to zero by doing nothing, right? Like locking everything down. And then
Right.
what you do is you open that door entirely to strategic risk, which is, well, what's the risk of not doing these things? Like if I'm not using models for preventing fraud, if I'm not using better kind of like model risk management controls, like, and so understanding that like organizations have like kind of like gone through that pendulum once or twice, and like it's the same way about thinking about security, and that's been a really good framing of like how we should be thinking about machine learning and the acceptability of risk, right? Which is at the end of the day is what most of these governance and controls are like, does the risk reward ratio work for the business focus of the organization? And as long as you understand what the risks are, you can take those, because it's about minimizing the risk that you don't want to take when it's not in
Exactly.
and that
You
flexibility.
You gotta find the balance between going as fast as you possibly can with no controls versus so many controls that you can't move at all.
Yeah.
And
Yeah,
there's a middle ground there that allows you to move quickly with adequate controls, and that's the balance you want to try to find.
And this is one of those things where, where does MLOps come into this, which is if you start thinking about the operational and the automation controls out of it, is like the more you can automate these, frameworks around risk, make assessments, where it's going to be using, put those through the right approval process, be able to kind of like remove the manual steps, then you can say, okay, this is a low risk thing that I can fully automate. I don't need to go through all these automated processes. So like thinking that automation aspect versus ones where you want to put stop in the tracks and say, I want 17 approvals in a very manual way for this.
No, you're right. If you've got that platform and that process in place, then you're really increasing the speed limit of the organization.
Yeah.
The company can deploy faster, move faster, and be confident that something's not going to, go bump in the night.
Yeah.
So legacy models, I talked a little bit about. One chief model risk management officer I spoke with at a top 10 bank, I said, do you know where all your models are? He said, well, I know where all the models are that were created by our data scientists and, in our analytics groups. He said, but I know there's a bunch of models, outside of the formal groups. And he said, those I don't have a lot of visibility into. And, there may be models that were done, years ago. One bank that I worked with actually found a model buried so deeply in its deposit system that, they nobody even remembered it was there, never mind knew how it worked. And this model was approving overdrafts and could be exploited by fraudsters. So, doing a really thorough sort of one-time, search to make sure that you uncover all these legacy models is really important, because they can be the source of some nasty surprises.
So when we go into the next one, which is, okay, how do we actually monitor and manage the operational health of these models? And so there is a kind of 3 levels to be really thinking about, so first of all, let's start with the fact that most of these models live inside an application, right? And there's an operational system, there's an application that lives there. So it's not just monitoring the model and making sure it behaves, but the entire application, it needs to be understood and monitored. And there's a whole bunch of IT systems that have already been usually created inside an organization to monitor application health. So how do we bring full visibility of that application, which now has an analytical model or an analytical pipeline or machine learning model in that understanding of it? How do we understand that, like, if there is problems with the model, what the accuracy looks like? And so being able to automate these machine learning models to have in applications, to have included in them already the monitoring capabilities. These needs to go hand in hand with that monitoring, alerting, and and observability. And so when you start thinking about, okay, well, what do I use inside my banking systems for software monitoring? What do I use for observability? What is the telemetry around software that we already create? Great. How do we bring these machine learning models and that telemetry data into those systems? Because in most cases, the first line of defense, something went wrong in an operational system, will not be the machine learning team. They will not be, it will actually be the SRE team. The teams that own operational systems at these organizations will likely be the first line of defense. So being able to bring automation around alerting problems with the model and include that in the vision of, hey, something went wrong with my network, or we're not getting requests, or a data source went down. We need to be able to build automation so that these models and the software and they live actually are showing up in the right place for that right first line of defense, and then being able to allow that next best action. In some cases, might be going back to the data science and machine learning team to say, hey, we think there's something with the raw model, time to go in to do some spelunking into what's going on and with the data and the features, and understand that and do that. In other cases, it might be, we lost a Kubernetes node, or we, like the application is no longer connected, and that's a different team. So how do we actually make sure that these new operational systems that are powered by machine learning are participating in the right alerting, first reaction time, and kind of next best action workflows over an organization is super important for an AI governance framework, because this is how you actually get that reaction time. So going back to that first kind of like three circles that go into each other, how do we make sure that that time is as fast as possible? We need to be able to bring that data back and do the right alerting there. So then we move into kind of a little bit more on that. So health monitoring and accuracy. So when we talk about, how do we get full visibility into how models are behaving? Becomes important. So HP talked about this, in the first couple of questions, which was, sometimes the changes are really subtle. Sometimes we actually, it looks like it's producing results. How do we understand if there's anomalies? How do we actually get to that? And, how do we actually create automation to be able to create these standards and these alerting frameworks? You want really to be able to be, integrating, real-time monitoring into the accuracy of any decision, being able to have controls over that. And again, going back to how do we go to that first alerting system and bring back the right person who can act, or person or people or approval process that can go check on that and make sure that there's not any changes. So, and these happen at the data level, at the model level, also at the kind of at data and the model level. So there's kind of two controls around that. And quick reaction time becomes really important. So going to a specific example, when COVID hit, a lot of these risk models went, a little bit out of whack. And I think I'm being that's the technical term, out of whack. So people's buying behaviors were very different. People's saving behaviors were very different. Job uncertainty. And so quickly being able to understand that the environment around these models is changing very quickly, and being able to go back through that process, is being able to alert that there's something wrong, understand that accuracy of these models might be off, and go through the entire process again, right? We need new data, we need to train new models, we need to deploy new models, we need to go through the approval processes based on a flexible framework of those models, and put them back into production, and make sure that they're working appropriately. How do we create that loop is really about observability at every single piece, and being able to capture that data and put it into the right system and have that reaction time. It really is about speed of going through in automation. And this is kind of where you really want those tools to be able to manage and monitor your operational health of your models in production. So when then going into production, this is something that gets ignored a little bit, but is extremely important. How do we talk about security and controls? Well, guess what? IT security and operational controls are not new. And they're definitely not new to the banking industry. And if anything, there's extremely strict standards around what kind of compute can be used? How do we actually, avoid the risk of security breaches? How do we, these are systems that, because they manage money in a lot of cases, are very, very keen targets for bad actors. And organizations in financial services have built very, very deep knowledge in kind of the security controls and operational aspects of any sort of software and computation. So when we start thinking about how does machine learning get into production, how do we operationalize, machine learning, it is extremely important to be thinking about how are we going to integrate into the IT security and compliance, network security, system manipulation systems that exist today inside those organizations. How do we bring the world of advanced analytics and integrate it into that? So this is things like thinking about how you're going to build your Docker containers, how are you going to go create these APIs and access management, how are you going to actually control what data goes through what system, what network can be used. How do we build and rebuild these systems so that you can actually make sure everything's patched on a regular basis? And so when we start thinking about the governance framework, this actually borrows a lot from a traditional IT framework, which is what's the threat model of this system? And once I've built the threat model of the system, okay, what are the aspects of that threat model that need to be included in the governance of this AI, operational system, so that we can actually, actually get it out. One of the things that we've seen over and over again is teams moving very quickly in a good way with all the right compliance and audit controls about models, and they're like, hey, we're ready to go to production. And guess what? You're actually 6 months away of getting a security review to make sure that all the systems are certified by your IT ops and your IT security and DevSecOps teams. And so one of the things that's important to think about in the MLX success in this frameworks is how do you bring those processes in early, all the way to planning, right? If the goal of these models is to get to production, which obviously it is, and be able to drive the operational systems, how do we bring in the DevSecOps teams early on into the conversation to understand the standards that we need to comply by? We need to understand how we need to build our MLOps systems, and how do we automate to be able to participate into those IT security governance models that already have been decided as standards inside the organization.
Yeah, so change management. Before I jump into this, I think it's important to recognize that you're dealing with a new animal that crosses organizational lines. Typical when you're dealing with data change management, it's usually under a chief data officer. And when you're dealing with model change management, it's usually a chief analytics officer, or maybe it's model risk management underneath the chief risk officer. And the problem is that you really can't do either in isolation anymore, because data affects models and models may affect data. So the problem is that you need to somehow integrate these two, so that as things change, whether it be new models or model methodologies or usage of models, or upstream or downstream data changes, either in the content or the structure, that you understand the potential impacts sort of both ways. To give you one example, one chief consumer credit officer I spoke with told me about a time where a critical feature in one of their credit models just suddenly disappeared from the data stream. And that data was no longer getting factored into the models. And nobody noticed for a while. And the problem was that somebody had changed something upstream, and without realizing the potential impact to that particular model. And all of a sudden, without any alarms going off anywhere, right, that feature was missing now from the model inputs. And again, that's a it's not as easy as it used to be, where data changes could be handled, and model changes could be handled. Now they have to be looked at together, and there needs to be an integrated approach. I'm not necessarily suggesting that you take all of change management and put it under one, like, massive organization. I think that would all actually be counterproductive. But I do think there needs to be like formal communication channels now between kind of the data engineering people and the analytics people. And let's not forget the IT people, right? Who have like an infrastructure and technology stack change management process. And, there now needs to be really good communication and coordination between all the stakeholders, so that, so that any change that could impact either, the operation of models or the usage of models or the quality of models is understood, and it's tested, it's validated, and if necessary, remediated before something explodes.
And the final one, who doesn't love audit? But actually creating standard audit reports and logs, including model results, change history, data errors, model failures, and any actions taken. And there's really three big reasons to have this. So one is from an audit perspective, like actual external auditors, right? The who, called, what, when, with what data, and why that HP talked about in the first is like really, really important. So being able to have a full history of the audit like becomes extremely important from that perspective. Hey, I need to be able to collect all of this. I need to be able to understand what it is, and I need to be able to package it and send it to an external potential auditor or a third party at a given time. That's kind of the first layer and kind of table stakes. But there's two other ones, which is the other one is like security audits, right? So who accessed the system? Who was the person calling the models? Where did that happen? Going back to those security and controls that are so important, being able to understand where in the system, what service accounts were being used and being able to trace that security aspect throughout the entire system and provide those audit report logs. Because if there is a breach, this is the first place that you're going to be going and looking for, what was the problem, who was the problem, what happened. And the reality here is there's no software system on earth that is completely impenetrable, right? But you can actually reduce the risk factor of it. So, this is really about understanding everything that's happening inside the system, being able to capture that, and again, integrating into the security systems that exist. And then the final one around audit is cost controls. So as more and more organizations have really built out a massive amount of these computationally intense machine learning models that are using, inference is growing in cost, who pays for this, right? So I have these operational systems and the compute associated with it, and these audit logs will actually provide you with chargebacks and showbacks and being able to understand, hey, the model risk team and and wealth care management is using this amount of compute, and they should be paying their part out of their P&L of that cost. The other the other teams are using this. So the audit and report logs has kind of like three categories of usefulness with the same data, which is one, being able to provide what's happening and who's happening and why that's happening. From a security perspective, in terms of access controls and threat models and like who has access to the systems, and finally from a cost controls perspective. And all of these are around really being able to capture in a standardized way all these audit reports and logs to be able to build out that information from that perspective. So we're starting to get here towards the end. I want to open up for questions. For those of you who don't know, this will be the only time I pitch the product. Algorithmia is an ML operations and management platform. We help you with the deployment of, connect models, load them, catalog them, version them, validate them from production. We help you manage costs and control the infrastructure with deep monitoring and observability across the entire platform, with the entire goal of delivering models and services at high velocity within a governance framework that is appropriate for the financial services industry. And obviously what we've been talking a lot about today, a keen focus on how do you enable high security systems, integrate into the IT security systems, and provide, reduction of risk, right? Around users, data, infrastructure, and models when operationalizing machine learning. So we'll open up for questions now, and please reach out to HP and myself. We love chatting about this stuff, obviously, and we'll take some of the questions here that have been in the chat.
Yeah, Diego, couple questions on ethics.
Yeah.
One from my old colleague Srini. Thanks for joining, Srini. Yeah, great questions. And that's I think where the framework, the governance framework, has to address that. And there's two particular issues that are really significant. Number one is what data is appropriate to be used for predictive modeling. Just because you can use a piece of data for modeling and it's informative and it gives you some signal, doesn't necessarily mean you should use it for modeling. There's obviously a lot of questions from regulators, for example, around the use of personal information that reveals something about demographics, right? Like gender, ethnicity, and or age, right? I mean, these are things that 20, 30 years ago, you might have used in a model without a thought. But now there's a lot of very good questions about whether it's appropriate to use those things in a model, because the model may learn to favor one demographic over another, right? Just based on your history, that may not be appropriate or may not be fair. So you really have to look at not just is the data that's being used accurate, but is the data that's being used appropriate? And could you stand up in public, right, and describe all the data that your model is using with a completely clear conscience, right? I think that's sort of the litmus test. The second question is, are you really sure that the training data is unbiased? And there's lots of sort of famous examples of models that are trained on a set of data that itself was the result of implicit bias in decision making, right? Like people hired or not hired, credits approved or not approved, overdrafts paid or overdrafts denied. I mean, and if there were people making these decisions historically, and you're using those decisions to train a model, whether to make those how to make those decisions in the future, then you really have to make sure that the data that you're using, that the decisions that people have made in the past, really don't contain subtly embedded biases, within the model. And this is where trust and explainability becomes a real big issue, right? You really need to be able to explain every every prediction, every decision that's made as a result of those predictions, and trace it back to the data that drove that decision, and make sure that you're really comfortable, right? That you can explain and defend the use of that data. But really good question.
Yeah, I mean, just to add to that, I mean, and then going back to the risk framework, in some cases there is no ethics concerns whatsoever, right? I mean, like if we're doing anomaly detection on networks, right? Like there is no ethical concerns about that, and so trying to bring in trying to get in to bring in an ethical framework or a compliance framework when there's no relevance to the use case is important as well. So I think it goes back to what are we doing? Is there a relevance here? And does trust in AI obviously this is required in a bunch of use cases, but in some cases, what's the penalty of getting it wrong? And I always use I like to get the the typical one I say is like the recommender of like, your favorite shopping site, right? You just bought a barbecue and you got another barbecue suggested to you. Like, is there an ethical standard there? Is that a problem for you? No, not really. So why would you actually go through the work of, building it? Like, could you make your recommendation better? Yes. What's the affordability of getting the answer wrong? Very low. And so a very a very high affordability. It doesn't matter. So that's kind of like, when thinking about ethics, I think there's a time and place in the kind of like world, but it's not a blank statement that like it needs to be applied to every single model that's being used in in a financial services organization.
Yep, absolutely. Another question here, Diego, about financial services moving to the cloud, moving to a data cloud. Mm-hmm. Great question. And, I think in some organizations, I think the whole information security, data security issue is a little bit of a red herring. It's an objection that's tossed up, as a reason really not to do anything. And when you start to really peel back, the layers and understand sort of what are the security concerns and what's valid, right, and what is perhaps less valid, I think you begin to understand that a lot of the cloud providers, I would argue, have better controls than some of the, say, mid-tier banks, for example. And if a mid-cap bank really thinks the data is safer because it's in a box they can see, right, versus in the cloud, I think they're kidding themselves. Now, there is vulnerability in the transport, right, in sending the data to the cloud and in getting data back from the cloud. And you do, of course, need to have controls over who can see what data in the cloud. But it's a really good question. And I think, over the last just 2 years, I've started to see, a sort of almost a uniform layer of resistance, right, to moving to a data cloud beginning to crumble, because the benefits are just so overwhelming, right, in terms of cost, speed to market, administrative burden, the ability to scale very quickly, right, up and down, the elimination of huge capital, right, expenditures in order to put infrastructure in place that you only need, at certain surge, capacity times. I think that's beginning to crumble. But I'm still seeing it in a lot of places. But I think, again, if you start to peel it away, I think where the vulnerability is in the transport, and if you can address that with the appropriate level of encryption, and make sure that there are the right controls on sensitive data in the cloud, so who can use it and when and for what purpose, and where who's visible to. I think those concerns are addressable, and I think I'm beginning to see an acceleration to data cloud, just because of the ability to scale up and down so fast, right? Depending on where you are, say, in a monthly or quarterly cycle, or where you are in terms of model development, or what you need at a particular time, based on a lot of people hitting the same data at the same time. Great question, though.
Yeah, one thing to add here, Mary, on this is, it's interesting because like there's not a single financial services institution on earth right now that doesn't have something in the cloud, right, or a cloud, right? In most cases, it's multiple clouds, and there's a difference between saying, hey, we're moving everything to the cloud, or we're going to be entirely cloud-based, or we're going to actually, and most of these large financial services institutions are using more than one cloud, as well as continuing to use their high investments in on-prem that they've made, right? CapEx investments that they've made in their private clouds. And it's interesting because there's these blanket statements of, we don't move this kind of data to the cloud. Well, if you start digging into that, and this is where I believe bringing in the DevSecOps teams early into the ML process is so important, is like there's ways of getting stuff running in the cloud, and they're building it for different applications and for different systems. And the sooner that the ML and operational teams get like up to date with what those DevSecOps teams, like bring them on the journey, the faster you can actually move some of this. So, if you go ask, can we move this to the cloud, or can we do this in the cloud? The first answer is always going to be no, because that's like the starting point is like no by default. Right. But when and that's fine, right? There's a reason for it. But when you start actually working through the processes and see, okay, this is what the data is, and this is what we're going to be using, this is what the system is, these are the threat models that have been built for this cloud environment, you start seeing that like that no starts turning into yes if, right? Yes if these conditions are met. And again, a big part of this is organizational and people oriented. But the earlier you bring in these teams and your automation around teams, and you can actually showcase your operational system in terms from a machine learning perspective, how it integrates into their security paradigm, these conversations go a lot easier.
Yeah.
As a follow-up, are places like FINRA and SEC starting to use the cloud? I believe so, and for certain use cases, around that. Like I've seen definitely FINRA has started using some cloud. I know the SEC has some cloud there for internal workings. So there's just a assumption that again, if you can. It's all about risk assessment, right? If you can prove the risk assessment is adequate, if the controls are adequate, there's no reason why you can't have highly sensitive data in the cloud. It's just usually something to hide behind. Again, the initial answer is no, and it's trying to move to a yes if. And a lot more of those conditions are being met, and we see financial service institutions, and it's not a one-way street, right? Like one thing that I've seen with a bunch of the different banking customers that we work with is there's no intent to do everything in the cloud, right? Like it's more about when it makes sense and where it's advantageous versus the kind of traditional on-prem. So modernizing infrastructure, operating it, like they want to take advantages of the best of the cloud, and as well as the best of their kind of on-prem deployments. And I think that hybrid model is here to stay. Which brings its own problems around security and governance in itself. But it's not a one-way street where it's like just trying to move everything over and call it a day.
I think the best argument for moving to the data cloud, I mean, there's arguments over which is really lower cost, right? And, about the transition cost. But I think when it comes to capacity, right? So many companies struggle with, do we really build the capacity we need for the maximum, right? The time of the quarter or the time of the year where we're going to need, 25 times the capacity that we would use on an average day, or when you have to build an analytics model based on, hundreds of millions or billions of rows, say for fraud, right? You don't need that capacity for very long, right? So companies struggle with either throttling the usage of their infrastructure or overbuilding their infrastructure to have the capacity for those times of surge demand. And I think the economics of the cloud and just the ability to get the capacity you need, both compute and storage, when you need it and not paying for it when you don't, to me is just sort of overwhelming in terms of the arguments.
Yeah. Well, it looks like we're on time. I know that HP and I could probably talk about this all day, nonstop. Thanks everybody for attending. And Patricia, off to you.
Thank you, Diego. Enjoyed it.
Thank you both so much. I know this audience is giving you a huge virtual round of applause because that was awesome. We really appreciate you sharing this content with us today. So thank you both. All right, to everyone joining us, thank you again for spending time with us today. Remember, you can contact Diego and HP with the information they provided at the end of the session. So we thank you all so much, and we look forward to seeing you at future AI4 events. Have a wonderful day, and we'll see you soon.